My name is DS Mabroor Haider, and this is my submission for the PM Accelerator Data Science Tech Assessment. I built a weather trend forecasting solution using the global weather repository dataset from Kaggle that we were given. As you can see here, this is my full Python notebook. I have uploaded it onto my GitHub repository for everyone to review. But for today's presentation, we will be using this report I generated without any of the code and all of the comments and the output. So it's easier for us to follow along. So I worked on a data set with over 60,000 rows of global weather data. I cleaned and pre-processed the data set by handling missing values, standardizing column names, dropping necessary columns, and also standardizing some columns. As you can see here, some of the columns data are severely skewed, which give incorrect or inaccurate graphs. This part of feature engineering. There's a correlation heat map which shows us which features are related to each other. For example, here UV index and air quality ozone have a strong negative correlation to humidity. Okay, so over here we have our temperature anomaly detection, which is also something we were asked to do. So for forecasting temperature on a long term, I used ridge regression and XGBoost. And after evaluating both ridge regression 1 with a better mean absolute error score and mean squared error score. After that, we have the feature importance map of air quality indicators and temperature compared to each other, and a higher number means a higher correlation. After that, we have several scatter plots showing air quality versus various features. So for example, temperature between a range of 0 to 10 and 30, these are two peaks where air quality is pretty bad. And after that, humidity. Higher humidity means worse air quality. Higher UV means better air quality. Higher wind speed means better air quality. After that, we have a few maps. The first map is a map of global temperature. We can see that mainly places close to the equator and places with dry and arid climates have the highest temperatures. These blue countries have the highest rainfall. Africa has the highest UV index, being closest to the sun, as the Earth is on a tilted rotational axis. This is a map of pressure. This is a map of wind speed, showing that mainly coastal areas have the highest wind speed. And finally, we have a map of humidity showing the Americas and New Zealand as having the highest humidities on the planet. So to conclude, we completed climate analysis through extensive data cleaning, feature engineering, and exploratory analysis, developed and evaluated ridge and XGBoost models for temperature prediction, analyzed air quality and climate data to find environmental impact, analyzed and visualized geographical patterns in the data through spatial analysis, and for future improvements, we may include seasonal decomposition, deep learning, or ensemble modeling. Thank you very much.